Hello dear students, welcome back to Chandu Biology Classes. So as a part of our discussion for GATE Excel 2026 and 2027, so here we are covering the previous year questions from GATE Excel 2025 as well as GATE Excel 2026 chemistry part. And I hope you know that there will be almost 17 questions from chemistry part in your GATE Excel. Those are compulsory questions, you need to attempt all of those, right? So now here you have maximum of 25 marks from chemistry subject, right? So if you are really aiming to score your rank below 100, you should not skip this chemistry part, right? So now I suggest you to focus on all the videos that I have made in this channel, whatever related to chemistry. So that videos will cover and highly helpful for all the students who are preparing for GATE Excel as well as IIT JAM BT. Okay, right. So let's begin our discussion on GATE Excel 2024 paper. In the last session I have covered 2025 paper, right? So now here you can see this is a very easy question. The correct order of electronegativity for the given elements. See what are the elements they have mentioned: aluminium, silicon, phosphorus and sulfur. Okay, so now here if you write oxygen, let me change the colors of pen. Okay, so we know fluorine is the highest electronegative element in the periodic table, and after that oxygen is the second most electronegative element, and after that nitrogen is the third most, or nitrogen and here chlorine are all having almost equal electronegativity values. Now and after this, see from the elements we have here, so you just consider sulfur will be the next electronegative element, and the next here if you see this side, you just come this side. So if you move this side, these are electropositive elements, these are electronegative elements. So here what we have? Phosphorus. So now out of this we can easily say sulfur and the next phosphorus, and phosphorus if we come this side, silicon, and if we still come this side, aluminium. That's it, we got the answer. Now first most electronegative from the given elements is sulfur, and after that phosphorus, the next silicon, least is aluminium. That's it, we got the answer. So where do we have that option? D. That's it. So this is a 1 marks question, and you no need of spending even 2-3 minutes also. Within 1 minute or within 30 seconds you can answer this, right? Yeah. So I hope it is clear. Let's move forward. Yeah. So this question, see guys, one more thing I will tell you. Just read the statement once. So the next question here, which of the following is the correct representation of variation of Gibbs free energy of a substance with temperature at a constant pressure? See, we have a relation between Gibbs free energy, temperature and entropy and enthalpy. What is the relation? See, first of all, the basic one, G is equals to H minus Ts. Okay, yeah. From this direct equation also we will get the answer, and one more equation at constant pressure they are saying now. You can use this or differentiation of this. Okay, so delta G is equals to delta H minus T delta S. This equation valid at constant temperature and pressure. Okay, now using this equation we can say a reaction is spontaneous or not. Okay, yeah. So these two equations are very, very important. First of all, let us answer this question. Next we will discuss about this extra, because from any of these we can expect a question again. Okay, so see here what they are asking us to draw G versus T right now. So from here what I can say, G is equals to minus T, otherwise G versus T now. So y axis G, x axis T I should take. Okay, so what I can make here, this one as a first term, minus S into T plus H. Can we write like this? So now it will become, so y equals to mx plus C type graph. Okay, so now try to draw this, Okay. So here G, here T. Okay, slope is negative, intercept is positive. It means something like this. Okay, so now try to draw 3 lines like that. because they are asking for solid, liquid and gas. So different physical state now. So where do we have more entropy? Gas is more entropy. Okay, more disorderness of the molecule means free movement of electron, like species will be taking place in gas. So it means, see, whenever you are drawing a graph, if you are drawing graph with negative slope like this, if you are drawing, the one which is having like this, okay, if I say this is 1, this is 2, which is at the bottom, that will be having more slope, like this you can understand. Okay, now see, which is having more slope, which is at the bottom means like slope should be more. Okay, so which is having more slope in all this thing, see, this is negative, this is negative, this is positive, it means it is incorrect. Okay, again this is negative, might be from A, C, or this one, is this correct? No, this is positive slopes, so this is also incorrect. So either it can be from A or C. Okay, now what I told you, where you are seeing more slope here, see, the line which is like this, see, which is having more slope, you need to identify. See, out of this, see, this line is having more slope, you can see. So the disorderness, minus S value is more for the above line, I can say, right? So gas is having more entropy now, so it means it should have a more negative slope. So more negative slope is here only. Okay, so it means which curve is correct out of this AC? Yeah, that's it. Okay, now when you are drawing slopes for positive, it means it will be going like this. The one which above will be having more slope. Okay, just remember these 2 points. Okay, next. What about histidine? See, among the following, the structure that representing histidine. See, I suggest you to go through all the amino acids list. Okay, 20 amino acids list you just make. Okay, and the structures, I am saying the structures. Okay, so now the question will be like this. The next question will be like this. Proline ring containing amino acid, pyrrolidine containing amino acid. Proline is a pyrrolidine ring containing amino acid. Indole ring containing amino acid, tryptophan. Okay, imidazole ring containing amino acid. Like that we can expect the question. So here in histidine we will be having imidazole ring. So now how the structure will looks like? Tell me which is the imidazole, all of like structures are imidazoles only. Okay, but which is a perfect representation of histidine? Yes, tell me which is the perfect representation of histidine? See, you just remember, here we have one more nitrogen, here one nitrogen. Okay, so one pi bond, another pi bond, here one nitrogen, hydrogen and the nitrogen. Okay, so you just leave this, the next carbon here we have now. So on this our chain will start, CH2, CH, NH2, like COOH, like this we have. Okay, so where do we have such thing here? See, this is in deuterion form, I can say. Okay, now tell me where do we have, see, this is not the one, NN side to side, this is incorrect. And here these are also, see, our linkage is between NN, is this correct way? No, this should be in this manner. Okay, see, it is in between 2 nitrogens, so it is also incorrect. Now next tell me between these 2. See here one carbon, next on this alpha amino acid means this is perfectly correct only now. See, NH, NH, the next carbon is left blank and the next carbon attached with this one. So perfectly C. Okay, is this correct or not? Right. See, I told you that's it, this is correct. Okay, that's it. Okay, next. So look at this, the correct order of acidity of the following compounds. What is the order of acidity of the following compounds? How can you answer this? See, acidity means what? An acid, if AH is an acid, it should release H plus ion and it should form a conjugate base. See, after releasing the H plus ion, we will get a conjugate base. Now try to remove hydrogen from all of this H plus ion from all of them. So if it is releasing H plus ion, we are going to get a compound like this. Yes or no? Lone pairs and H plus ion. From here also you just remove one H plus ion. Out of these two, one H plus is released. One H plus is released, I am saying. Okay, that's it. Okay, from here also you do the same thing. If one H plus is released, this is a conjugate base formed. That's it, no? So now if you see this second structure, after releasing H plus ion, we are getting an aromatic species. Yes or no? See, lone pairs, sigma bond, pi bond, so conjugation is there. So it's, what is the name of this cyclic ring? It's called a pyrrole. What is this? Pyrrole. So pyrrole is an aromatic ring. Okay, since we are, see, this is not an aromatic ring. Why this is not an aromatic now? Because the lone pairs here are not in conjugation. See, for aromaticity I told you 5 conditions. If you forgot, please watch that aromaticity video. So what are the 5 conditions? Compound should be cyclic. First of all, compound should be cyclic. All the carbons or the atoms present here should be planar. What I am saying? Planar. Okay, it means planar means either they should have sp2 or sp hybridization. Okay, next. So complete conjugation of electron should takes place. So complete conjugation is there or not? Just check. See, pi bond, sigma bond, pi bond. Again sigma bond, lone pair. So they are in proper conjugation. Conjugation system is there. So complete conjugation should be there. Okay. Then next one is, fourth condition should be, it should obey 4n plus 2 pi electron rule. So 4n plus 2 pi electron. It means n value just put n equals to, you just put 0, 1, 2, 3 like that. Okay. So just see, by inserting n is equals to 1 over here, how many pi electron system we are getting? So 2 plus 2 into 1 plus 2, 6 pi electrons. See here, 2 pi bonds, lone pairs. See, when these lone pairs are involving in the conjugation, what happens? Lone pairs become a pi bond. So it means we have 6 pi electrons here. Okay, those 6 pi electrons are having complete conjugation. Compound is planar, cyclic. So pyrrole is an aromatic ring. Okay, so a non-aromatic compound, see, if it is having H plus ion attached to it, it is not a aromatic. Why not aromatic? Because the lone pairs are not present here on the nitrogen, they are making a bond. Okay, it's a non-aromatic compound. After releasing H plus become a aromatic. So it's a stable species formed now after releasing H plus, that's why it is highly acidic. See, a species is moving, see, what do we mean by acidity? This species release H plus ion, it means it should move forward, reaction should go forward. So the reaction will go forward if the species formed after releasing H plus ion is more stable. So conjugate base stability is more, then this will be more acidic. So that's why this second compound is more acidic. Okay, is this clear? So where do we have options? Only one option is there with second option, second one more acidic. So directly you can keep option B as your answer. Okay, now if you want to justify between 1 and 3, yes, it is also easy. See, here there is no conjugation, but after releasing H plus ion, lone pairs are in conjugation with this pi bond right now. So conjugation make it to be the stable system. So that's why it is second most acidic. Okay, so 2, 3, 1. So B is your answer for the question. Okay, right. The next. So now look at this question, what they are saying, the molecule with molecules A, B are pair of, what is the relation between these two compounds they are asking. Please observe them clearly, very very clearly, you just observe the difference, what makes the difference between them. Please tell me, just identify and tell me what makes the difference between them. Position of, it's correct only, position of. See, this ring, nitrobenzene ring, is attached to the carbon here, okay, which is a phenyl ring side. But here in this case, this is in cyclohexyl ring side, okay, like pyrrolidine ring side. But here it is towards this benzene ring side. So that makes the difference now. Are they same structures? No, they are differ in the, chemical formula is same, but they differ in the complete structure itself. Okay, bond connectivity is itself different right now. So we can say them as a structural isomers. Can we say structural isomers? The other name of structural isomers is constitutional isomers. What is that? Constitutional isomer. Direct question now. Okay. So now I will tell you one more example. See, this is a IIT JAM question. Whatever I am making, I will be try to match with the IIT JAM question, because previously I have seen that. This is A and B. What makes the difference between A and B? How they related? NH not connectivity is everything same. Connectivity is same, but spatial arrangement is different. This is above the plane. Here it is below the plane. It means you just take anything like take a mirror and you just place an organic molecule. So if I place a mirror over here, what happens? And above the plane species become below the plane. So it means A and B are mirror images now. So if these are mirror images, now see these are mirror images or not? Yeah. So now consider this is my one hand, okay, and its mirror image will be like this, right? So now you try to take this real image and keep it on the mirror image. Are they superimposing? No, right? So we can say these as a non-superimposable mirror images. What is this? Non-superimposable mirror images. So these are called enantiomers. What they are called? Enantiomers. Now what is the relation between A and B? Enantiomers. Okay, is this clear? Right. So they are also, see, if you won't observe this, you are going to keep the first answer, choosing the first answer will give you a wrong. See, they just change the plane here. So if you only consider that, you might be thinking it as enantiomer. First option itself, it is wrong. But they made the difference in the structure itself. Okay, that is the last option. So here you have a trap. Okay, please be careful while solving these easy questions. Okay, do you got the difference now? What do we mean by enantiomers? Okay, right. In the last class also I have explained what are enantiomers, diastereomers. To go from one enantiomer to another enantiomer, configuration becomes opposite, I told you. If it is R, it becomes S, I told you. If it is S, becomes R. Okay, this discussion we did yesterday's class also. Now look at this. The correct options of Y from the following reaction is R. So it means it's an MSQ type question, multi-selective type question. Yeah, try to answer. Yeah, see, this is called, see, 1, 2, 3, 4, 5, 6. At 2 position, at 4th position we have nitro groups. 2, 4 dinitro phenyl hydrazine, we can say. Phenyl hydrazine. What is the formula of hydrazine? NH2. NH2 is called hydrazine. So in the place of hydrogen we have this ring. So 2, 4 dinitro phenyl hydrazine. So this 2, 4 dinitro phenyl hydrazine, upon reacting with carbonyl compounds, what I am saying? Carbonyl compounds. It can be aldehyde or it can be ketone. What are the two things I am saying? Aldehyde, ketone. It will form yellow orange crystals. What they form? Yellow orange crystals it will be forming. Okay, so that is called a hydrazine. The product formed upon treating with ketones or aldehydes called as hydrazone. What is that? Hydrazone. See, 2, 4 dinitrophenyl hydrazine forming 2, 4 dinitrophenyl hydrazone. Hydrazine gives hydrazone. That's it. Okay. So now what you need to identify from the 4 compounds, you just need to identify which is whether aldehyde is present or ketone is present. Only those will react. Now tell me what are the options you can choose. Do we have aldehyde? What about the first option? Aldehyde. Yes, this will react and gives you yellow orange color hydrazone. And this is ester. No. Oh, C, ketone. That's it. Very easy now. Okay. It means you just need to be aware of the reactions. That's it. And if they ask us to represent the structure or the product formed, structure of the product formed, if they ask, what you need to do is, see the carbonyl compounds, it means aldehydes or ketones. So it means aldehydes and ketones, what they will do, see this oxygen, see out of these two nitrogens, this terminal nitrogen is nucleophilic, it will donate the electrons. It means these hydrogens and this oxygen removed as water. After removing water, what is the resulting species we have? So this is called 2,4 dinitrophenyl hydrazone. That's it. This is an yellow or orange crystal formed as a product. That's it. Okay. See, this discussion we did yesterday. Please try to answer me the question for this answer. The maximum number of electrons that can be accommodated in a shell. See, what do we mean by shell? If this is a nucleus, structure of atom we discussed this concept. See, if this is a nucleus and these are the orbits we can say, or shells we can say. Okay. So in shell, for example, here n equals to 1 we are saying, n equals to 2 we are saying. So when I say n equals to 1, we can have 1s orbital. Okay. If I say n equals to 2, what are the subshells we can have? 2s, 2p, like this we can have right now. So now what I will tell you one simple way to answer this, but I just want to give the concept also. So at second level, what are the shells, second shell contains what are the subshells? 2s and 2p. So s can have one orbital, but p can have how many orbitals? 3 orbitals are there. So each orbital can accommodate how many electrons? So 2, like total number of electrons, no? 8 electrons, no? So how do you get this answer? See, I will tell you some simple formulas to get this. You can do this, but it's a lengthy way. See what I am saying, in a shell, in a nth shell, the number of subshell possible is n square. How many subshells? See, this is shell number. Shell number is n. So number of subshell possible are n square. So it means n equals to 1. Number of subshells possible are only one subshell, S subshell. N equals to 2. Number of subshells possible are, number of orbitals possible are, see, n equals to 2. So number of orbitals I am saying. Subshell number is 1 means 1 orbital. If 2 means 2 square we can write now, so it will be 4 orbitals. 1, 2, 3, 4. So it means if I give n equals to 3, number of orbitals possible are 3 square, 9. What are those 9? That can be 3s, that can be 3p and 3d. So d orbitals are 5, p are 3, 1 is s. Total sum is 9. Is this clear? Got the concept? And if I say n equals to 4, 16. Okay, right. So in each orbital how many you are filling? 2. So you got the number of orbitals as n square. In each orbital you can fill 2 electrons. So you just take 2n square. This gives you number of or maximum number of electrons that can be accommodated in a shell. Okay, now tell me if n equals to 2, how many electrons we can fill maximum of? 2 into 2 square, that is 4 to the 8. So it will be 8 electrons. These are the proof. Okay, is this clear? You got the concept?
When do we use this formula 2L plus 1 for subshell and 2 of 12 plus 1 is there?
2L plus 1. Okay, if L equals to 0 we are taking. So L0 means this is s orbital. Okay, so it means how many orbitals are there in s subshell? 1. So for finding orbitals in a subshell, we are using this formula. Okay, yes. So for answering this, we can get, we can use this one also, but it won't works here. Okay, this is the best formula you can use because they given n value now. See, if n equals to 2, L can be 0, 1, 0, 1. If again, see, this is a lengthy process. L means 0 means S, P. Again here 2, here 6, all these calculations you need to do. Okay, directly you can use 2n square is the best formula to be used here. Okay, anyways, in the exam whatever comes into your mind, you go with that method, but this is the best method I am giving you. Yeah, then next, look at this question, what they are saying. If you haven't watched thermodynamics, yes, you can see this, you can directly answer if you have watched that. See, 1 mole of an ideal gas expand isothermally, it means temperature constant, reversibly to double of its volume. If V1 is a volume, expand it to 2V1. Okay, if the expansion, okay, if the expansion work done by the system is this much, W is how much? 1728.85 joules. Okay, the temperature of the system, it means we need to, this T constant now, what is that constant temperature we need to find. So the work done formula will be work done equals to minus 2.303 nRT log V final by V initial, V2 by V1 we can write. Okay, so now since we are finding temperature, no need of worrying about this negative sign. What that negative sign is indicating, its work is expanding, like work done by the system. It means here also negative, this also negative, you can remove. Okay, so what we are going to get, 1728.85, 2.303 into N is 1, R is, they are saying it is in joules now. Yeah, take 8.3 mentioned here, 1.314 joules into temperature we need to find, log V2 is 2V1 by V1. So log 2 is 0.3010. So just simplify this. I think you can use what is it, calculator, you can get the answer. Is this clear? Okay, right. The next question here, again this is also easy, but whenever I have seen some scenarios here, in GATE and IT exam definitely we require a specific answer. They will give some range, our answer should fall into that range. Okay, always try to use calculator wherever it is possible. Okay, because I have solved these two questions. When I am doing, if we do simple approximate calculation, we will get out of that range. So always try to use the calculator. Okay, and I know most of the students will skip doing or usage of this calci. Okay, please practice with a calculator, that scientific calculator whenever it is possible. Try to attempt some online exams only. Okay, do not just stick to the pen paper exam. Okay, so yeah, this is from my own experience I am saying. Okay, see the initial rate of reaction triples. It means a rate, see reactant A forming some final product. Okay, so the rate of reaction depends on concentration of reactant. So it might be having some order, I am indicating with M. So this is how we will indicate. Okay, so if concentration of reactant increases, rate also increases. You got this point. Now read the statement. The initial reaction triples, it means it becomes 3R when the concentration of reactant A is double. It means it is becoming 2A to the power M. Okay, do you got this what I am saying? You just take the ratio of these two other ways. Okay, so this is R1 I am saying, this is A. So if you take this is equation 1, this is equation 2, dividing 2 by 1 or 1 by 2, what you get, see it is becoming 3R1 now, so R1 cancelled. So here I can write this one as R1 is equals to K A power M by R2, that is nothing but 3R1 is equals to K 2 power M A power M. Can I write like this? Yeah, so like this. Okay, K also cancelled. Okay, R1 cancelled. So one other ways, R1 also, yeah. So what they are asking, order of the reaction. Okay, order of the reaction only they are asking, no? So it's easy. Okay, so 1 by 3 is equals to 1 by 2 power M we got. Okay, so I can write 2 power M is equals to 3 I can write. So what is the value of M I can place to get this value, to get this answer? I should put a value over here in the place of M so that it should equals to 3. So what is a simple way we can do this? Apply log on both sides. Okay, so what I am doing here, log 2 power m is equals to log 3. So I can write m log 2 is equals to log 3. So m equals to log 3 by log 2. So you will get the 0.47 by 0.3010. Again use your calculator to get the exact value. Okay, do you got the concept? Okay, do not directly write the answer, but please try to use it a calculator and do it. Okay. Yeah. So again round off to 2 decimals. Okay, someone in the comment box, please sir, please biotech students के लिए केम का one shot. Okay. See, this is what is this? Doraemon Dora. So please try to watch whatever the live sessions I have made for chemistry in this channel itself. Okay. So I think I have covered most important topics that must be focused to score the maximum possible marks from chemistry part using those important topics. Okay. So after that you just watch these PYQ sessions, it will be really helpful. Yeah. The next one here, see, each of the following alkenes undergoes addition reactions with bromine. Okay. Under the same reaction condition, the correct trend in the reaction rates means which of these 3 molecules having more reactivity, rate of reaction they are asking. Okay. So to get this answer, before this just listen to my explanation once again. Okay. These are 3 alkenes I am giving you first. Tell me the stability of alkenes. How can we explain the stability of alkenes? Alkene stability depends upon number of alpha hydrogens present. What I am saying? This is the alkene carbon, this one and this one. Adjacent hydrogens are there now. It means adjacent hydrogens means not this directly attached hydrogen. Adjacent carbon is called alpha carbon. On that how many hydrogens are there? Here 3, and for this also here we have 3 alpha hydrogen. So 6 hyperconjugations we will get. 6 alpha hydrogen, 6 hyperconjugation. For this 3, 3, 3, 3. 12 alpha hydrogens are there, 12 alpha hydrogen, 12 hyperconjugations. For this only 3 alpha hydrogens, 3 hyperconjugations possible. So where do we have more number of hyperconjugations? This one, B. So B will be more stable. Okay, so B is more stable, then A, then C. So this is how you need to decide the stability of alkanes. Okay, so why we are discussing this, I will tell you again. See here, I just want to add few more points also. Bromine is there now, bromine. So this bromine is in liquid in state. Which state? See, I will tell you one question. Like F2, Cl2, Br2, like this we have now. So now I2, like this we have now. So if you see these elements having different physical states, means they will give a question like this. A group of elements having 3 physical states. It means in a particular group some elements are having gaseous state, some are liquid, some are solid. So that group element best example is halogen family. This is a HCU question, previously asked HCU question. So the first 2 are gaseous, this is liquid, solid. Okay, remember this. Now here bromine is in liquid in state and it will be having reddish brown color. What is the color? Reddish brown color. So whenever we are initiating the reaction, at the beginning of the reaction, what is the color of the solution? Reddish brown. Now as this bromine is consumed during the reaction, for example it is reacting with an alkene like this. Now what happens to the color? Once it is undergoing the reaction, it will be keep on consumed in the reaction. So at the end of the reaction, let us say it is completely consumed. Do we see the color of the reddish brown? No. So we can say alkenes upon treating with bromine water, it will decolorizes. Can I say decolorizes? So by looking at the decolorization, we can able to identify degree of unsaturation, unsaturated compounds. It means what exactly here? If I give you alkene, do this alkene contain any pi bonds? No, it is simply like CH3 I can write. So here I can write alkene means CH2 I can write. See, a pi bond is there. This is what reacting with the bromine. Okay, so it means alkenes are considered to be unsaturated compounds. Only unsaturated compounds will be decolorized as bromine water. It means we can separate saturated or unsaturated compounds using bromine water, or we can identify saturated, unsaturated compounds using bromine water. Sir, you are saying only alkenes, why not alkynes? Yes, alkynes also considered to be unsaturated compounds. Okay, so alkynes, alkenes, both are unsaturated compounds that can be identified from saturated compounds like alkanes using bromine water. Okay, you can remember this. Not only bromine water, we can also have KMnO4. KMnO4 color is violet color, potassium permanganate. Okay, so purple I can say otherwise. Okay, that can be also reacts only with unsaturated compounds, not with the saturated. Okay, right. Only from alkanes, only those type of alkanes will react which have this tertiary hydrogen containing compounds. Tertiary hydrogen containing alkane will react with KMnO4, not any other alkanes. Okay, remember. Okay, this is an extra discussion because whenever we see a question, we should go throughout it so that we can expect a question from that. Okay, now here you got the stability of alkenes. Okay, so here if you see, when I am adding bromine, what happens is, see, bromine lone pairs are there now, so they will get repel each other. So now what happens is bond becomes weaker. Okay, so this bond try to break. Okay, so let us say when these pi electrons are given this side, this bond is taken by one bromine. Okay, so that see this bond is connecting to the bromine through this carbon. So here it is losing the pi bond right now. So what is the charge we are creating? Positive. To that, bromine will use its electrons like this. It means we are getting a 3-member cycle. Okay, so during this 3-member cycle, for a small instant of time, what is the charge here we are creating? Positive. So positive charge means carbocation can be stabilized by what type of groups? Donating groups or releasing groups I can say. So here I have methyl group and I have simply carbocation here and I have CH3 positive charge. So which is more stable? 1, 2, 3. More number of electron releasing groups now. So 3 more stable than 2 more stable than 1 we can say, right? So now apply same concept over here. Okay, see if this bromine, this pi bond is, see these are the pi bonds reacting right now. So if you see, if this pi bond is reacting, one carbon should get a positive charge. It means one carbon is getting positive charge means something like this you are preparing. Okay, if I react with here, so let us say this carbon is getting positive charge, it means that can be stabilized by this adjacent electron releasing group. Do we have any electron releasing group here? But here we have. In this case, if any of this carbon is getting positive charge, what type of group attached? Carbonyl group means this kind of group is there, means it is electron withdrawing group. But withdrawing groups destabilizes the system now. So which is least reactive here? Withdrawing group containing. So one is the least reactive. Do you got the concept what I am saying? See, there should be electron releasing group to stabilize the positive charge generated here. Okay, so that can be stabilized here. So it means out of these two, which is more reactive? Second. So in between them, 3. So where do we have? This one. Okay, that's it. Do you got the concept? Now let me finish the reaction also. Okay, so yeah, so we are going to get bromine, a 3-member ring like this. Okay, after forming this 3-membered ring, see we know 3-membered rings are unstable. Okay, now what happens, out of these 2 bromines only 1 bromine is reacted, another bromine is having negative charge now, so that will attacks at one of the sides. Okay, sir, which side it is attacking, second bromine, how can we decide? Yeah, if these alkyl groups are different, for example here 2 alkyl groups are there, so just try to open the ring. If I open this ring, we are getting a positive charge for some instant right now. Again try to open here, where do we get more stable carbocation? This more alkyl group side more stable, okay, because more electron releasing, there you add second bromine. Okay, like this if we have means here the second bromine, here this first bromine, like this we need to add. Okay, so this is extra discussion plus concept I have discussed here. I hope you got the concept. Okay, next question, this is from enzyme catalysis. Okay, you must be familiar with this. Yeah, tell me what is the Michaelis-Menton's constant and all these things. What is the equation that we'll get the equation now? Line-Weaver-Burke plot. Do you aware of this? Huh? No. Okay. Okay, I will explain. No issues. Have you heard this Michaelis-Menten constant? We'll represent with Km. Huh. See, during enzyme catalysis reaction, the rate of reaction depends on enzyme concentration, here I am writing, and concentration of substrate, okay, and there is a constant K2. Okay, I am not going to derive all this equation, just I am giving you the final derivation, final result. Okay, and in the denominator we have K2 plus concentration of substrate. This is what we will be having. Okay, so now this equation, what I am saying, rate of reaction will be maximum. It means R maximum when all this, see what is the use of enzyme? It's a catalyst, it will speed up the reaction. Now what I am saying, rate of reaction is maximum. In order to make rate of reaction, this all enzymes should be react with the substrate. It means what I can make here, so E should be completely reacted with the substrate. So it means, can I say this is also maximum? Okay, because enzyme should be reacted completely. So I can say R max is equals to V max into substrate by K2 plus concentration of substrate I am writing. Okay, right. This together I am taking it as V max. Okay, even if you won't take like that also we will get the answer, but extra point I just added there. Okay, so this is K2, not K2, this is Km in the denominator. Which one? Huh. Different people represent in a different manner. Okay, so I am representing in this way. Okay. So anyways, what I want Line-Weaver-Burke plot. So how it will be? 1 by R max will be equals to, take reciprocal of this, Km by V max and concentration of substrate plus concentration of substrate by V max into concentration of substrate. That's it now. Just take the reciprocal of this, Km by this one as a denominator, concentration of S by this one, in between plus sign. Okay. Now try to cancel out this. What is the remaining part we have? Tell me. What is the remaining part we have? What is the remaining part we have? See, 1 by R max is equals to Km by V max S plus 1 by V max. Okay, right. So now what I am doing is, I want to convert this into the data mentioned. What is the data mentioned here? The Line-Weaver-Burke plot for the analysis of an experimental data has an intercept along the y-axis. What is the intercept of y-axis? 0.357. Okay, and slope is 2.10 seconds. Now what is the exact value or correct value of Michaelis-Menten constant they are asking. Okay, it's very easy. We want to get this Km value from this equation. see, try to convert this as 1 by R max, y equals to mx plus c graph I am trying here. So Km by V max to 1 by S plus 1 by V max. Okay, so this is C, this is X, this is M, and this is our Y. Okay, see what they are asking us, Y axis and X axis they have mentioned. So this is Y axis. So how the plot looks like, 1 by max and here 1 by S. Okay, now how can we draw this? Something like this only, now like this we'll get. Okay, so now what is the intercept they have mentioned? Intercept is 0.35 and slope is this much. So slope, first of all take the slope out of it. What is slope here? M. What is that? Km by V max. This is how much value mentioned? 2.10 second. Okay, and what is the 1 by V max, that intercept mentioned? See how much it is mentioned, 1 by V max. 0.357 into Km. What are the units also? Please take the units. 0.357 millimole inverse decimeter cube second. Okay, into Km is equals to 2.1 second. So you can remove this second. Okay, so our answer will be Km is equals to 2.1 by 0.357. Units will become reciprocal. So millimole decimeter cube inverse. Okay, so this is, see, almost I can say 21 by 3.57. Okay, so it means 21 by 3.57 means 3 sevens are 21, but here 5 7 is there now. So as per the options you can see these are the two options we can expect, right? 5.88. Okay, so you can say this is 5.88 millimole decimeter inverse, cube inverse. So we have first option only. See, units also important now. Okay, so you got the answer as A. So this is the value of your Km. Okay, I hope the concept is clear. Try to write this this equation and all. Done? Yeah. Okay, this 22nd question. What is it saying? Which among the following structure is most stable conformer of Z pent 2E? Z, Ez. What is this Z indicates? Z, E and Z. I think I have explained this Ez also in the class. Okay, see cis trans we have now. Okay, like that after that we have discussed about Ez. So whenever there is cis trans won't work, I mean even if it is working we will be taking Ez. So this will be given based on the atomic number, that is called CIP rules. Okay, more atomic number first priority, like that. For example here carbon double bond is there. So chlorine, bromine, iodine, fluorine I have. So based on individual carbons, which is more atomic number here, so it should be first prioritized. In this, so how they are oriented? Opposite, trans na 180 degrees na, opposite, anti-form na, so you should call it as E, entag again, E. Okay, otherwise if they are same side. Tell me here in this case. See, bromine, chlorine, 1 1. So it should be called as Z configuration. Z isomer, E isomer. You got the concept? Okay. Next one here, they are asking, it is mentioned as Z isomer. Z means that priority group should be same side of the pi bond. Okay, that is clear. And the next one is most stable conformer they are asking. So look at the each and every option mentioned here. First of all, find Ez in out of this. First one ERZ. See, double bond is a hydrogen least priority, methyl first priority, here also this alkyl group. So this is an E isomer or Z? Z isomer. Perfect. This one? E isomer, opposite side, na? E isomer. So no need of bothering about this. Next, this one? Z isomer, yeah. So might be A or C. This one you check? So no need of bothering about this because they mentioned clearly in the question Z isomer most stable. So it means out of A and C we need to give the answer. So how can you mention this, tell me? Yeah. See, whenever there is non-polar or some alkyl groups, if those are bulky groups, considered to be bulky groups, because if I say this is a double bond, methyl group is there now here, like this. Okay, here also some alkyl group is there. So it also contains some alkyl chains like this now. What happens is between this alkyl group hydrogens and this alkyl group hydrogens, if they are aligned in the same direction, there will be some interactions. That interactions, due to that repulsive interaction, system becomes less stable. So what is the best way? We need to place them in different planes. That is the best way we can do. See here in this option, what makes the difference between here and there? See, methyl group are lying in the same plane, like within the plane like this. But here if you see, this is within the plane, this is above the plane, methyl group is above the plane. Will they have now this kind of interactions here? No. So which is more stable? C, that's it. This is your answer. Easy only? Right. Some basic understanding, basic analysis is more than enough to solve this kind of questions. Okay, again, here one more question. Fast. Tell me, read the question and tell me what's your answer. Read it. Upon adding of compound X to the to an aqueous solution of AgNO3, a white precipitate appears instantly. So also X does not exhibit any geometrical isomerism. So what is the correct option for this X they are asking? See, geometrical isomerism means in organic compounds, just now we have seen cis trans isomerism, Ez isomerism is example for geometrical isomerism. Okay, in organic compounds, that is in organic. Here it is coordination complexes, here also we have geometrical isomerism. Okay, so now geometrical isomerism, see all of them if you observe octahedral complexes only. Check here 4 plus 2, 6 ligands octahedral, 5 plus 1 octahedral, 6 octahedral. Okay, so now there are asking two linkages in it. First one precipitate, AgCl precipitate should be formed, other one is geometrical isomer. See, simple ma, whenever you are taking any complex, whatever may be the ion present inside this complex, whatever the ligands or metal complex inside of this square bracket, that is what we are saying it as complex. If you place this in water, in which medium? Water, it will not loses its identity, it will remains as it is. Won't lose its identity. It means it will not undergo any dissociation, I am saying. Okay, but here along with the complex, if there is any extra ions like this out of this coordination sphere, whenever you place in the water, what happens is this coordination sphere become one ion and this another extra ions, whatever the ions outside the sphere becomes separately. It means extra ions whatever here we are having, that comes out as a ions. Do you got what I am saying? So now just tell me, I am adding NaCl plus AgNO3. What is the compound formed? AgCl plus NaNO3. See, NaNO3 is an electrolyte, but AgCl is a white precipitate. What it is? It's a white precipitate. That's it. I hope you got the concept what they are asking us. In these given complexes, if any chloride ion is present outside the coordination sphere, that will be precipitates upon treating with AgNO3. Inside chloride ions won't come. If any present outside, that will comes out and precipitate as an AgCl precipitate. Okay, now tell me, first complex will instantly give precipitate or not with AgNO3? Yes, because we have one chloride ion, upon treating with AgNO3, we will get an AgCl precipitate. You got this. Second option also we have two chlorides. Yes, this is also gives. Third option also gives. Fourth option, no. So we got eliminated one option here. Next, out of this ABC, they are asking, it is a multi-selective question. Okay, right. So now out of this three, they are asking us to does not exhibit geometrical isomerism. Okay, so geometrical isomerism is possible. You got this concept now? Whenever there is ions outside the coordination sphere, will get ionizes, but inside the sphere they won't get ionized. It will remain as such. It will not lose any identity. Okay. So now what I am saying here, geometrical isomerism, octahedral complexes. See, in order to say cis-trans isomerism, if this is a metal, we know octahedral complex means metal at the center and like a square, and above the square one, below the square one. Okay, let me make a square first. This is a square. So whatever the ligands present in this square at this terminal are within the plane. See, it's a plane now, square is a planar species, right? It's a plane now. So above the plane I am placing one line, below the one. Okay, so now all the ions which are all the ligands which are at 90 degrees relation to each other are cis to each other. What I am saying? If they have 90 degrees relation, cis to each other. If they have 180 degrees relation, trans. So cis trans is it, these are only like geometrical isomerism means. Okay, so now what I am doing is I am placing ligand, four ligands. Now all these red color ligands are cis to each other. Can I say cis to each other? Right. Now what I am writing here, I am writing some here L dash with this orange L dash. Okay, how this L dash are related to each other? L dash, they are 180 to each other now. So I can say this is a trans isomer. Okay, see, trans with respect to L dash. Now see what I am changing. Here I am putting L dash and here L. What happens, tell me now? How this L dash and L are oriented? This is L dash, this is also L dash. What is the angle? 90. So you can say cis. So this is a cis isomer, previous one is. So it can have MA4B2 type complex. It means 4 of same type, 2 of different type. So it can say cis trans isomerism like this. Okay, is this clear? Okay. So the next one, if I have MA5B type, will it show geometrical isomerism? No, it won't be, because you got to know that at least 2 must be difference. With respect to 2 we can able to say, but here all 5 are same. How can I differentiate with respect to B? We cannot do now. So MA5B cannot show. See here you can have MA5B type. Will it show? No. So you can eliminate this. Now there is a possibility. See, MA4B2, yes, cis trans is possible. Chlorines, these 2 chlorines, don't bother about outside chlorine, it comes out. Okay, inside only you check. So chlorine, cis to each other, trans to each other. So A is possible. The next here, all are same. MA6, will it show? All are same. All the ligands are same. Will it show cis trans isomerism like geometrical? No. So eliminate this also. Now that's it. See this one MA3B3 type complex, right? Yes. Here we have a one more concept, it will show geometrical isomerism. I am not choosing the answer, but extra adding a point. It will show geometrical isomerism, that is called facial and meridional isomers are formed. These are the two isomers possible for A3, B3. Just remember this. But this is accepting the geometrical isomerism, but will it precipitate? So it means we eliminated this previously itself. So ABC you just remove. Only A is perfectly correct answer. Does not exhibit. Okay. So does not exhibit means okay. B and C will not, does not exhibit. If it is exhibiting, they are asking only exhibiting. So they are asking does not exhibit means BC. You got the concept? Yeah, I am happy for that. Okay, you can choose this BC. That's it. Okay, right. Next. Clear now? Any confusions are there in this? No. Okay, and this is a 2 marks question. This one, yesterday I have given you complexes. See, one complex question definitely we are seeing in the exam. Okay, it means you should not skip coordination chemistry mark. Okay, so I think I made only 1 or 1.5 hour video. So please watch on it. Okay, and see, more than that only they are asking, but I covered maximum in a crisp manner. So try to watch it. The paramagnetic species among the following. Can you solve this based on yesterday's discussion? See, in the video if you see, there are the ligands mentioned here like this. Cyanide, what is the ligand here? OH2, that is nothing but H2O only, water. Aqua ligand you can say. Here it is again cyanide, again cyanide. So cyanide ligands are strong field ligands. Okay, water is a weak field ligand. Okay, now what I told you, whenever there is a complex formation, if there is any possibility to pair up the electrons, these strong field ligands will pair the electrons of that metal. It means I will tell you for one example, you can do it for other. Okay, so here you can take iron. Okay, so plus what is the oxidation state? Find that. Cyanide minus na Cn minus. So X plus 6, each cyanide is -1 oxidation state. The charge present on it -3. So X will be no +3. So this is the oxidation state of iron in the first complex. After knowing this, what is the atomic number of iron? 26. So if I write only iron atom, see they mentioned here anyways, 26, how do you write the electronic configuration 26 now? I told you in tricky way yesterday. Okay, argon over, after that 3D 6 4s2. Okay, now how many electrons to be removed from this atom? +3 means 3 electrons. Okay, so it becomes 3d5 4s0. After this we have 4p also with 0. So I am writing an extra point here, 4p0. Okay, now how many ligands are there in the complex? 6. See, in metal complexes, each ligand donate pair of electrons to the metal. How many electrons? Pair of electrons. It means one orbital can accommodate 2 electrons. So like that, how many empty orbital this metal should have now? 6 orbitals are required from the metal. So for that, just write this orbital orientation, representation 1, 2, 3, 4. Okay, 5, done. Okay, so fill these electrons here. This is 3D. 1, 2, 3, 4, 5. Okay, done. 4s, 4p, 0. Okay, so now I required 6 orbitals. If you see like this, how many are there? 4 only there. Okay, if the ligand attached is strong field ligand, what it will do is, it will enhances to electrons to get paired up like this, and it will uses inner orbitals, inner d orbitals. If it is ligand is not having that capability to pair the electrons, that is in case of weak field ligand, it will uses this 4d orbitals. Without disturbing here, it will uses this 4d empty orbitals. In that case, it will form sp3 d2 hybridization. In this case, it is pairing the electrons. How many orbitals required? We have 4. Still, how many required? 2. So try to generate 2 orbitals by pairing the electrons. This is empty. like this. So we'll get D2s, one cyanide, second, third, fourth, fifth, sixth. 6 cyanides are using them. So we are going to get a D2 sp3 hybridization. Okay. Now do we have any unpaired electrons after making this complex? Yes, we have one unpaired electron now. So it can be a paramagnetic substance now, paramagnetic complex. Okay, do you got the concept? Octahedral with dsp2 electronic hybridization with a paramagnetic nature. Okay, and I told you how to calculate even magnetic moment also. Mu is equals to n into root over n into n plus 2 Bohr magnetons you can use to get the answer. Okay, so can I say first complex is paramagnetic? Yeah. Now one more tricky way I will tell you. Whenever there is odd number of electrons, it's a paramagnetic. Okay, just given you the concept. Now what I am saying, whenever there is odd electron, it will be a paramagnetic substance. Now find the electronic hybridization for this. Ni plus 2 here. Ni plus 2 means 3d8. 3d8 means 5 over 6, 7, 8. Okay, 8 up to here for nickel. See, even if you pair this, we are not able to create 2 empty orbitals. And water is a weak field ligand, so it does not have capability to pair up. So it will use this empty, this one. So we are having empty, unpaired electrons. So it's a diamagnetic or paramagnetic? This one, paramagnetic. Okay, this is also paramagnetic. They are asking paramagnetic only. Nickel, can you try for this? Yesterday only I did. This is a diamagnetic substance. In 2025 it is asked. Now also it is asked. Okay, it's a diamagnetic species. Okay, for this one, find its oxidation state. Find first. Plus 3. So chromium plus 3 means what is a hybrid electronic configuration? Chromium 24. So 3d5 4s2. Remove 3 electrons. 3d 3 electrons you are removing now. Plus 3 oxidation state means 3d3 odd electron now. So what I told you, odd electron means definitely one unpaired electron. So paramagnetic. Directly we can answer. Okay, you got the concept? Okay. So as an extra work, I am just expecting answer from your side. What will be the hybridization for option C and D? Those who are in the live session, please give me your answer in the comment box. Okay, and please try, whoever watching this, and tell me your answers in the chat box. I will be looking to it. Definitely I will help if there is any wrong in that. Okay, so find their hybridizations for CD, hybridization for CD, and number of unpaired electrons you tell me, and also tell me whether paramagnetic, diamagnetic, and also its magnetic moment value also you mention using this formula. Okay, that's it. So where n indicates number of unpaired electrons. Okay, right. Yeah. So few last questions, 3 questions are there. Anyways, I will cover only one. Remaining 2 we will discuss in the next session. Okay, right. So the molecule with non-zero dipole moment. So non-zero. So mu should not be equals to 0. They are asking. See, whenever there is a homodiatomic molecule, what I am saying? Homodiatomic molecule, dipole moment will be 0. See, N2 is there. It's a homodiatomic molecule now. Both interactions, both forces same, so mu will be 0. And CO2 is there. Just try to get this structure. It's an sp hybridized molecule, like a linear molecule, okay, with the same terminal groups. So the net dipole moment will cancel out each other, so it becomes 0, mu 0 in this case also. Now NO, it's a heterodiatomic molecule. See, heterodiatomic molecules, definitely there will be non-zero dipole moment, right? Because different electronegativities, mu is equals to what? Charge into distance. Okay, so charge created now here because due to different electronegativities. So this one. Next, SO2, find its structure. Try to find its structure. Bent shape. I told you what is the tricky way to solve. Sulfur now, sulfur which group element? 16th. 6 valence electrons will be there. Highlight them like this. 6 over. So 1 oxygen because it's a divalent. Okay, 1 lone pair. So 2 sigma bonds, 2 pi bonds. No need of bother about pi bonds. Find sigma bonds how many? 2 sigma bonds, 1 lone pair. So sp2 hybridization. sp2 means it should have a trigonal planar, but 1 lone pair is occupied. So sulfur one lone pair. See, whenever it is not having ideal shape, see ideal shape means if it is having trigonal planar shape only, like SO3 if you consider, how it will be? Like this. So dipole moment will cancel out each other, it will be 0. But here lone pairs are there now, always towards itself, oxygen towards itself, okay, but not exactly equal. So there will not be equal dipole moment, it's a non-equal. So non-zero dipole moment will be seen in this option also. So CD will be a perfect answer, okay. Molecules, MSQ, okay. So CD is your answer, okay, right. Okay, for these two questions also, I will give you one hint, you can solve, okay. If not, I will explain in the upcoming session. Anyways, just listen. What is the pH of water, what is the pH scale indication from where to where we will be seeing? 0 to 14 we will be seeing at 25 degrees Celsius. At what temperature? 25 degrees, okay. So now remember, why we got pH is equals to, pH place, pH scale means it will be having basic medium and acidic medium, both now. pH plus pOH is equals to 14 we are saying, this is at 25 degrees Celsius. Why we are getting this? Because at 25 degrees Celsius, if you consider water dissociation, one water molecule will dissociate to give one H plus and one OH. So overall H plus ion, OH minus ions are equal now when one water molecule dissociate. The value of H plus ion at 25 degrees is found to be 10 power minus 7. If H plus ion is 10 power minus 7, OH minus also 10 power minus 7. Okay, this is at what temperature? 25 degrees Celsius. Now that's way, if I say for this water, if I ask for dissociation constant, how do you write the dissociation constant? Concentration of H plus into concentration of OH minus. This is what dissociation constant, an ionic product of water. Product means multiplication, ionic means these two ions, ionic product of water. So what is the H plus ion? OH minus also, multiply them, 10 power minus 7 minus 7, it becomes minus 14. This is KW, okay. So now, can I write it is equals to 10 power minus 14 here, okay. So now apply minus log on both sides, like if I apply log of A into B, log A plus log B, minus on both sides, minus log concentration of H plus minus log concentration of OH minus equals to minus log of 10 power minus 14. So minus log of concentration of H plus is nothing but pH, minus log concentration of OH minus means pOH, minus log 10, 1 minus 14 I can write here plus 14. So that's why we are getting pH plus pOH as 14. So why we are saying this concept, I do not want question to answer explanation, I given you the concept. Now read the statements. Ionic product of water at 40 degrees means temperature changes, ionic product value also changing. See, ionic product of water at 25 degrees is, but here at 40 degrees it is 2.92 into 10 power minus 14. So ionic product is changing. Now, so how can you say this? It means when water dissociate, we will get equal number of H plus and OH minus. So ionic product H plus and OH minus is equals to 2.92 into 10 power minus 14. This story is at 40 degrees Celsius. It means temperature is increasing now. So as temperature increased from 25 to 40, dissociation also increasing. It means this water is getting dissociated as we increase the temperature. So can I say it is an endothermic process? Endothermic, it means high temperature favors forward. Do you got this concept also? Extra point to be added. Okay, next. Now what I am asking you, ionic product of water, then they are asking pH of water. So what you can say here, you got this value. Okay, so the next what I am going to do here is pH of the water. Okay, fine. See, concentration of H plus, concentration of OH minus product is this much. But we know concentration of H plus, OH minus are equal. Yes or no? It means, can I write this is, these are equal only now. This is something like This, let's say this value is 2, this value is also 2. 2 into 2, 2 square can I write? So similar to that, concentration of H plus ion whole square can I write here? Because both of them are equal only now. You got what I am saying? Now this is equals 2.92 into 10 power minus 14. Okay. So now send this to that side, you are going to get H plus ion concentration. Then apply minus log on this side and that side, you will get pH value. So write our answer here. Okay, do you got the answer? If you got this, please mention, those who are in the live session, please mention your answer in the chat box. And one last question, I do not want to skip this one also. The given standard reduction potential values for this cell is given, and they are asking Gibbs free energy for the dissolution. See, whenever they are asking Gibbs free energy, by mentioning potentials, you can use, see, energy means we know joules will be the energy, okay. So you can write 1 joule equals to charge into potential, like coulomb into voltage, okay. So here you can use delta G is nothing but maximum work done by the system, that is given as minus NF E naught cell. So this NF indicates, N indicates number of electrons, F indicates charge, Faraday's 96500 here mentioned, E naught cell means cell potential you need to take. So but the thing is, number of electrons finding here is easy. How many electrons are participating? 1, that is easy. Faraday also given, that is also easy. But finding E naught cell is a tricky way here. Okay, I will tell you the way to solve, then you can further calculate. See, what they are asking, Gibbs free energy change for dissolution of silver chloride in water. See, when silver chloride is dissoluting in water, what it will give you? Ag plus Cl minus. These are the ions it is forming now. But if you see, they mentioned chloride ion, but they haven't mentioned Ag ion. They mentioned silver metal. But what I want? So, without mentioning that, they given an extra step. Using this step, we can get that. What is that? How can we use this? See, Ag plus electron forming Ag. Means I want this product side Ag plus. But did they mention? No. So I am taking this equation in the reverse manner. So this is equation 1, equation 2. Take the reverse of equation 2. What happens? Ag gives rise to Ag plus electron. Okay, that's it now. See, for this forward reaction it is 0.8. For this reverse reaction it becomes E naught becomes minus 0.80. Do you got this? Okay. So now what I am doing is, this is considered equation 3. From 193, I am removing 1 electron reactant side, 1 electron product side. 1 solid silver product side, some solid reactant side, removed. So now what is the resultant we have from 193? AgCl gives rise to, in aqueous medium consider, gives rise to Ag plus Cl minus. We got our equation, that's it. So now for this E naught cell will be calculated by adding this equation as it is. So 0.22 this one plus of minus 0.80. So minus 0.8758. Okay, that's it. We got E naught cell also. The next what I told you, delta G naught is equals to minus NF E naught cell. So what you need to do, number of electrons participated in the reaction are 1, 96500 into minus of minus becomes plus, just multiply, you will get some answer, you just write here. And those who are watching in the live session, please mention your answer for this in the chat box. Okay, so thanks for watching. Whoever watching this, if you like the content, please click on the follow button and you can share with your friends and share your feedback in the chat box. Thank you for watching.